How's it going, everyone? Vlad here with SolosPLC.com, and in the last two videos on Siemens PLC programming, we've looked at how to connect to an actual PLC, followed by how to simulate a PLC as well as an HMI system in Siemens TIA Portal. Today I want to revisit the hardware and take a look at not only the PLC, the same one that we've seen in the last two videos, the S7-1200 series PLC, but also take a look at the data sheet and see how we can wire in some external inputs and outputs into our system. So we're going to be utilizing the example 6 sensor that we've seen a couple of times on this channel. We're also going to wire in a normally open push button, and then the output is going to be the LED of this push button that we're going to also wire into the PLC. So hopefully it's going to be very insightful how to go through the data sheet, how to figure out which wiring connections we need to make to those external components work, and then we're going to be wiring all that up and writing some logic to actuate the items that we've connected to our PLC. Without any further delay, let's get started. The technical manual for the S7-1200 family is quite extensive, and you should be able to find this document either on the Siemens website or directly on solosplc.com. That being said, if we scroll down to table A-43, we'll find a wiring diagram for CPU 1212C DC-DC relay. And what's extremely important is that you find the right specification for your particular PLC. The part number is going to be mentioned in parentheses, but one mistake that can certainly occur is if you get the 1212C PLC and then it has multiple configurations. So in my case, it's going to be a DC-DC relay PLC, and thus this is the right wiring diagram. So the first thing that we've already taken care of in a previous video is going to be the 24 volt DC power input. So that's going to be on pins L, plus, and M right here on connector X10. And in order to connect the inputs, we notice that we have a power supply, essentially a negative available on the 1M pin, and then we've got the digital I/O on DI0, 1, 2, 3, 4, 5, 6, 7. We've got two analog inputs, which we're not going to look at today. And last, we've got the relay outputs on the bottom that are going to source 110 VAC, which we're going to connect to power our LED. So let's make the hardware connections and then see what everything looks like in TIA Portal. Alright, so I made all the necessary connections offline, and I did want to go over them in order to make sure that there's a clear understanding on how to wire in these inputs and outputs, and namely the push button as well as the sensor that's going to be coming into this PLC Siemens S7-1200 CPU. So we start off by discussing power. So as I've shown you in a previous episode, power is going to be the first terminal on the left hand side. Next, we've got a terminal that's going to allow us to draw power for external devices, and that's what I'm going to be using for the 24 volts VDC to power our sensor. So you'll notice that there's going to be a blue as well as a brown cable leaving that terminal and landing on the terminal strip for my specific sensor. Now, we've covered this sensor a couple of times already, so we're not going to go in too much detail. But we do need power, and then we're getting one signal back on the black cable of the sensor, which is going to go back into input number 0 that you see on this first black cable right here. The next item that we have is the push button. So the push button is also going to be an input. As I've mentioned a few times, this is going to be a normally open push button. If I put it in front of the camera, you'll notice that the bottom terminal is going to be made once I press the button in. And as I release it, it's obviously going to be broken. Now, in order to feed the signal to the push button, we're going to need that same 24 volt power supply, and you will notice that there's a little jumper right here that's going to do exactly that. And then the signal from the push button is going to come back on the second black cable that's going to land on input number 2 of our PLC. So to summarize, on the input side, we've got the photo eye on input number 0, and then we've got the push button signal on input number 1 on the top side of our PLC. Now on the bottom, what I'm doing is since I do need 110 VAC based on the specification that you can see right here on the push button, I am landing 110 VAC on one side of the terminal, and then that's allowing me to toggle the LED that is currently placed inside of the housing of the push button. Now, to get that done, I'm taking that directly off the power supply. So I'm taking the line, I'm using the relay, so I'm going to open the output side, and you'll notice that we've got all of our relay outputs. So the common for the first 4 relays is going to come into this pin labeled 1L, and then the output of the first relay, which is going to be the relay 0, is going to go out and go into that LED status on the relay side. And obviously there's a signal that comes back and lands on the neutral wire through this white cable right here. In any case, those are all the connections that have been made. One thing that I will say is that I highly recommend that you don't make any of these connections on a live system at the risk of damaging the hardware and or yourself. So make sure that you finalize all the connections before you power on the PLC and test anything that you have connected. Alright, so we're not going to rediscuss how to create the logic because it's fairly straightforward based on the previous video. That being said, I do want to rediscuss the tags that we've tied back to the inputs and outputs. In the last video, as you remember, we've used the memory bits instead of the inputs and outputs. In this case, we are tied to physical I/O. So for the photo I1, I'm going to use input number 0, and for push button 1, I'm going to use input 1. And so that's going to be specified through this operand identifier, which we discussed last time. And for the LED, since we're using the relay output, we're going to use this Q0.0, which is the first relay output available on the PLC. Looking at the logic, if we go into our main, we can see that the rung that I wrote is exactly the same one as last video. And what is happening in this case is when the photo eye is made and the push button is not pressed, the LED is allowed to turn on. If the push button is pressed, it's going to reset the LED and it's going to turn off. So one thing that I had not mentioned last time, if we want to click on this monitoring on and off, so we're looking at this live at the current signals, and let's look at the screen as well and demonstrate the way this works. So I'm going to pick up the sensor and I'm going to make it using this retroreflective screen. So I'm going to put it in front of the sensor. As you can see, the logic has been made and the LED has been turned on in the logic as well as on the actual LED in the real world. Now, when I press the LED, or the push button, you'll notice that the LED is going to turn off since that signal is going to be made, and the logic is going to reflect that fact. Once again, if I make my signal using the retro reflector, it's going to turn on my LED. You'll also notice that the photo eye is going to remain off based on the indicator, which I really like the way it's shown in TIA Portal. And once again, if I click the push button, I'm going to reset the logic and it's going to turn off the LED. As you continue working with various peripherals tied to your PLC, it's important to realize that there's a better way than to toggle your sensors and your push buttons every time you want to test your program. And that way is called forcing, or at least it's one of the ways. You can certainly add an HMI and then start simulating your logic, but there is a way in TIA Portal to create a force value that would allow you to toggle some of these things through the PLC program. And that's going to be on the left hand side under the watch and force table section. We can expand that menu and double click on force table to see another tag table looking spreadsheet. So here I can start by selecting the things that we want to force. Under name, I'm going to select some of my tags. So let's select the push button. Let's select the photo eye. And if I want to test the output to my LED, I'm going to throw that in as well. So you'll notice that TIA Portal will automatically pre-create addresses that are going to be tied to the hardware inputs as well as outputs in this case. And so in order to force a value, we can start by double-clicking force value, and we can type in either true, false, 0, or 1. So in my case, if I want to simulate the photo eye, which I guess is the most difficult thing or most time consuming thing for me to toggle, since I do need to move this screen every single time. I want to force this to true. I'm going to press enter, and you'll notice that we'll get an error message or a warning message that's going to tell us that the address is selected but is not yet being forced. So we do need to enable forces just like you would in many other PLC brands. So clicking on this start or replace forcing, force all, click on yes, and that's going to essentially force this photo eye to always be on. Now, of course, if we go back to our logic, this renders the program somewhat unusable, and if we monitor as we did before, you'll notice that the LED is going to be continuously turned on. Now, if we go back to the force table, at this point I can force the LED to be off. So if I type 0, it's going to automatically go into false. Just like before, we get a warning that says that the address is selected but is not yet being forced. We do need to replace forcing, press on yes, and now we are forcing the LED to be constantly off. For obvious reasons, even if I try and press this button, there's nothing that's going to toggle my output. And you'll also notice that the indicators on the PLC are going to be responding as such. Now, there's a couple of things I do want you to pay attention to. So forcing is not something that you would typically do in a live environment. Obviously, if you do have to, this is one way to do it, but there's always going to be an indicator next to the PLC that's going to say that there are forces in place. And that's something to pay attention to, especially when you're troubleshooting, because if you, as I've mentioned a couple of times, if you go into your logic, you're going to also have indicators, but it does seem like the LED is being energized if you only look at the colors, and therefore it could be confusing to some of the new users. In any case, that's all we have for you today. If you want to explore with some of the hardware and software that we've explained, and leave us some comments in the section below or on the forum, we'd be more than happy to answer you.